Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Okay guys, so right, now into the demonstration. We're going to take a little look at what this technology does in action. This is the environment that we have set up. So we have an imaginary company with a domain controller and a victim PC on the left-hand side. We have a gateway running threat emulation, which is sitting in my network. And then over on the right-hand side, we have my command and control, or my attacker, my bad guy, trying to take control of the network. So as far as my environment, what does this look like? Here we go. This is my client PC, and on my client PC I can see that I have a couple of windows. So the credit for this demonstration goes to Ian Porteous, who's the SE manager for the UK, and what he was looking at doing is seeing how much bad activity you can do with macros. Okay, so what we have is a macro, or a couple of files that have macros in them over here. You can see the MD5s of files there as well. And what he found out was he was searching around the internet and he was looking for some PowerShell code that could pick up your username, your password, and your domain, and then send it to a unencrypted server. What he wanted to do with this code was to then embed it inside a macro-enabled Excel file, so that when you open the Excel file, it ran the code. When the code was run, it would then send the file, and you wouldn't be you'd be kind of none the wiser. The data was also base64 encoded, so again it just makes it a little bit more difficult to pick up. So if we take a look at the basics of the file itself, what it was Ian borrowed is this script here, and again he does give credit to the guy who created it. So here is the script itself, and what you can see is we're looking for the username, the domain, and the password of that person. And what happens is the script keeps running until you enter true credentials. So it does a quick bit of validation and says, whilst not equal true, keep asking for the credentials. And once you've done that, we're then going to try and take a few bits of information and URL encode them. We join that into one long line of text. So here is our CNC server on the internet, and we're going to send into pass.php the username, the password, the domain, the internal IPs if we can get them easily, and the external IP if we can also grab the information. Okay. Obviously in a lab it's a little difficult to grab the internal and external IPs. So if we try and take this code and run it ourselves, what will happen is Windows actually says no. Okay, and Windows says no because you're not allowed to execute scripts on this system, and it kind of tells you so. Now, over here, there is actually a command in Windows PowerShell that lets you give unrestricted access to the execution of code. And again, if I try and run it, it says still not allowed. So as a user on this machine, even logged in as local admin, I cannot execute scripts, PowerShell scripts on this machine. Now, if you see here in this other window, this is a PowerShell window which we're doing a run as administrator. So this is like the highest level of account on this system. If we change the permissions on here to say we can run code, then try and rerun our file, you can see that the internals are going to do, it's going to pop up this window, and the internals of the code are going to say, please give me your domain credentials, so demo/tom, and if I type in something that's wrong, click OK, it will come back, and again, because this is not equal true, the credentials are incorrect, it just keeps prompt until I put in the right details. Put in my demo username and password, and again, in the text here, you can see that we've got the user, the password, the domain, the IP address, and all of that information URL encoded, which is then sent to our web server. Okay? Now, if we go and look at our web server, what we can see in here is, again, user, password, domain, and the IP address from which I'm connecting. So let's just reset this setting back to restricted, just so that we can definitely demonstrate to you that there's no smoke and mirrors. So now we know that this code can no longer be executed by any normal person on the machine. So let's go to Ian's file, and just for ease of demonstration, I'm going to make a quick copy. And the reason I'm making a copy is because if I copy the file and run it again, what will happen is I will get a prompt at the top to say, do you want to run this file? This file has got macros, etc. built into it. So what we can see is if we run the file, when we run this file, we now get a prompt. Okay, so here's this kind of dummy file that we've created. Here is the file. It's password protected. It's confidential. To open it, please click the link that says enable content. And when we click the link, again shown up here, what we might notice is a quick flash up of PowerShell down the bottom there. There it goes. And again, I should get prompted for my credentials in just a second. So as this pops up, again, notice first of all that I am running this as a standard user. Okay, I'm not a domain admin. I'm not anything special. The problem here is because I've run this code from an application. So I've run Excel. Excel allows me to run macros. Macros allow me to call PowerShell. And then because we've borrowed this code that takes the credentials, again, if I type in anything that's wrong, doesn't work, you're not allowed, please enter the correct credentials, type in the correct credentials, and what will happen, again, is behind the scenes, my data's now been sent to the bad guys, and I am none the wiser. Now, if you want to see what it is and what this looks like, so if we take a look at the code itself, if we view the macros, we can see we've got the auto open macro, and as we said, as I said earlier on, Ian decided to base64 encode the script or the content of the script that you saw earlier on. So rather than saying I want the username, I want the password, I want the domain, it all just looks like gobbledygook because to the human eye this doesn't mean anything. Okay, so that's what's been run. And if we close the file and again go over to our LAMP server, again you can see the details have been sent across here. So, okay, well, would this have been picked up by an AV system? Okay, so if we take a look here, we can see the two versions of the file that we've been working with. One, you can see the last four characters, C3AB. This one here, 6E9C. Now, if we take these files and we put them into something like VirusTotal, so we can pick the option to choose a file, we can go to our documents, we can pick any one of these files, let's pick the copy that we've just made, and we send it to scan. What will happen is this will then get checked against around 60 AV vendors. And what you can see is just earlier on, in fact a couple of days ago when we previously ran the demonstration, it shows that nobody understands this file as being bad. Okay, so there is the evidence. 0 out of 57 AV vendors think this file is bad, and again, this is no discredit to any of those AV vendors. Even in here, you'll see Kaspersky, which is who we use as well. Because of what this file is set up to do, you just don't see anything malicious going on. Now, what I've done is, again, if we just take a look, this is an SSH session over to my threat emulation gateway, and what you can see is if we take a look at the MD5 sums, we can see that the MD5 sums of the two different files do match, so we know that this is the same file. And because we're on a protected network at the moment, what we're going to do is we're going to ask threat emulation to run this file on itself and just confirm whether it knows the file to be bad or not, and also create as a report. Okay, so if we have the threat emulation in blocking mode, the very first time the file is run, it may take 2 or 3 minutes for the file to be emulated. Okay, so we've got the device in blocking mode. The first time it's going to run it up to 3 times, maximum a minute each time, then wait for no activity. Then on the final run of the file, we are going to create the report. Now, on this gateway here, what we can do is we can run the file manually, and what you can see that the evidence here shows, because I have run this file on this box before, it was possible for the threat emulation daemon, Ted, to come back to me and say, actually, this is a bad file, confidence is high, the action should be drop, and the reason being is I have seen this file being emulated before, I know it's bad, I built up a cache, again the same kind of cache that gets shared back with Threat Cloud. And what we can then see in the reports is, if we take a look at the reports on the gateway side of things, we can see that localhost emulated a file called salary2015.xlsm. We can see the hash of the file, and if we open it, we can see that we have detected some malicious activity. In this example machine here, I'm only running one Windows 7 machine, and obviously because there's no PowerShell in XP, it will be pointless to run this on XP, but we can see a summary report, and in the summary report we can see the activity of the file overall, and we can see that it was detected as malicious, and we can see in which operating systems it was detected as malicious, and also see the different activity that we saw. So if we then click on that file itself, on the specific file, we see a screenshot of the file being emulated. We can see that things like PowerShell were run. We can see, again, a number of the other elements related to PowerShell that we saw. And as we go down through the report, we can see the start, and then early on in the emulation process, further and further on in the emulation process, and then as we get to the end of the report, we can actually see all of the different activity and all of the unexpected elements that we saw in the session. Okay, so this is something where all of the traditional AV systems out there wouldn't have been able to prevent this. Okay, so that's that for the demo side of things. So from a Q&A and summary side of things, what I'd like to just say is, obviously, thank you for taking your time to be with us today. So to summarize, the threat emulation is a key technology for what Checkpoint is now and will be in the future, and it gives you protection and visibility into those unknown threats. It's going to get better when we add in threat extraction and hyperwise. Okay, so again, just to quickly say thanks for taking the time out your diary to join us. As far as questions and follow-up, what we're going to do is, obviously, some of the questions that you may have may be specific to your environment, may be confidential, so either you can post them in the Q&A if you're happy to do so, or what's often preferred is if you route them via your account manager over at Bytes, or Shona will send you a survey at the end of the session, and if you can respond into there, then what will happen is we can make sure that every question gets addressed as soon as we can for you. Okay, so just want to say thank you from me, and I will hand back over to Shona, and she can just do the final wrap-up.
Thanks very much, Tom. So thanks to Tom from myself and obviously from the audience as well for a really comprehensive demonstration at the end, and also presentation of where Checkpoint are going as regards advanced threat prevention. Thanks everyone for taking the time to attend today. We will make the recording of this session, there'll be 2 recordings, one of the original strategy session, and then the second recording will have the actual demo Tom's just run through for you. I'll make those available, and they'll also be available on our website so you can share those with our teams. Thank you very much for joining us, and good afternoon.